today. And the first thing we're going to be talking about is called a glide reflection. And we'll get to a definition of that after we look through this example here. So the first question about this is there a single rigid motion? When it says, is there a rigid motion, it means one thing. Is there one thing we could do rigid motion wise to get from ABC to A prime, B prime, C prime? No, why not? Yeah, we have three kinds of rigid motions. We have a reflection, and it doesn't look like there's anywhere along here that would be able to reflect this one down to that one. That's not going to work. Translations. We can't move this to make it match up exactly with that one either. And then rotation, that's not going to work either, because if we rotated this 180 degrees, this would end up upside down over here, and this isn't upside down. So the answer is no. There is no single rigid motion that could result this one getting to that one by doing only one thing. So I'm just going to say no, or say there is no single, I'm going to underline that, rigid motion. We can't just do one thing to get from ABC to A prime, B prime, C prime. So then we have to think about, are there possibly two things that we could do to get from this triangle to that triangle? And that's mostly what we're going to be talking about today. Doing two rigid motions to an original figure to get to the second figure. So if you think about what's happening here, could you perform two rigid motions? If so, which ones do you think might work? I would say you're super close on that. I agree with your two rigid motions. A reflection and a translation are exactly what we're going to do. The reflection is going to be offset by just a little bit. But yeah, let's go with that. So on this one, let's talk about, well, which one would you want to do first? Would you want to do a reflection first or a translation first? Translation. I agree with that. Do you notice that these two triangles are like reflections this way of one another? I mean, they're definitely offset, but if we could get them to line up this way, they would end up mapping right onto each other if you were to reflect them. So basically, if we can take this one and move it down, we could then figure out where it reflects to make them end up being exactly the same. So all we need to do is match up the points vertically in order to then reflect after that. So if you were going to match this up vertically, how far down would you have to move this one? Because we're going from this one to that one. So how far down would you have to move this one to line it up with that one? 5, yeah. So if we move all three of these points down 5, let's do that. So 1, 2, 3, 4, 5, there would be A, and then 1, 2, 3, 4, there's C, and then B would be here. So that's a translation of down 5 units. And before we go any further, let's talk about B real quick. This is going to be a composition. So it says, does a reflection, translation, or rotation map triangle ABC to A prime, B prime, C prime? And it's actually a composition of a translation and a reflection. So let's write that. Composition of translation and reflection. In order to get from the first one to the second one, we have to do two separate things. So we've done one of them. And now we have to figure out where is that line of reflection. So we've got our translation. Now we need to figure out our line of reflection in order to actually make that work. So how far apart are, let's just pick B and B prime. How far apart are those 2 points? 4. So the line of reflection would have to be halfway in between those, 2 away from each one. So the line of reflection is a vertical line, and it's this vertical line right here. So in order to do the reflection, we would have to know the equation of that particular vertical line. And we talked about this a couple times, but vertical lines always have an equation based off of the value of x and only x. And so we can say that this line is going to be x equals what? Positive or negative? -1, yeah, because it's on the negative side in the x's. So this is going to be x equals -1. So if we translate down 5 and we reflect across the line x equals -1, that will get us from ABC to A prime, B prime, C prime. So let's go and write that down. So we're going to say we need, let's see, the order that we did these in is we did the translation first and the reflection second, which means if we write this as a composition, we should write the reflection first and then the translation second. So we're going to say reflection across the line, x equals -1. And then what symbol do we use for composition? If we're combining this with another transformation, what's our little symbol that we use? T for transformation, or translation, sorry. But composition, what's our symbol in between the two transformations that we use? Yeah, a little open circle, like that. So it's a composition of a reflection across the line y equals -1, and then we do the capital T for a translation, and then parentheses. How are we going to write this translation? We went down 5. That's all we did. 0 and -5. Good. Because we're not moving left or right at all for that translation. So that x movement is 0. And then the y movement went down by 5. So that'd be -5. So this is the composition of two rigid motions that gets us from ABC to A prime, B prime, C prime. Now, what do you notice about the example here versus what we did up here? There's 3 of them, but we have 3 as well. We put a third one here, but yeah, they reflected first and then translated. But that didn't change the answer. And so that kind of goes back to the warm-up where Paula's example was a reflection and a translation, and it didn't matter what order those were done in, which is true here too, because we translated and then reflected. This is a reflection and then a translation, and it still ended up in the same place. So the nice thing about writing a composition of rigid motions is we could have switched out the direction of both of those and it would still be the same thing. So when you write a reflection, or not a reflection, when you write a composition of a reflection and either just a horizontal or vertical translation, it's important that you're only moving in one direction. But if you end up doing that, it doesn't matter the order of those two translations or transformations that you do. And this is what's known as a glide reflection. So where did my highlighter go? I'm going to highlight glide reflection because that is the vocab kind of that we're learning today. So this is a glide reflection. And a glide reflection happens when you reflect, reflection followed by a translation in a direction parallel to the line of reflection. Basically, it means if you reflect horizontally, you are going to translate vertically, okay? If you reflect vertically, you will end up translating horizontally. And so that's what a glide reflection is. So it's a flip and a slide, or a flip and a slide. So whichever way you reflect, you are going to end up translating in that opposite direction. So horizontal reflection would be vertical movement. Vertical reflection would be a horizontal movement. So let's take a look down here. We actually kind of already did this. It says the grid shows ABC reflected across the line x equals -1 and then translated 5 units down. Draw the image of ABC translated 5 units down and then reflected across the line with x equals -1. We already did that. That was what we did right here. So we actually don't even need to worry about doing example 2 because we already did it. But it says we are going to write an answer to this question. What conclusion can you draw about the order of the rigid motions in a glide reflection? And I've already mentioned it. What can we conclude about the order that we do the transformations within a glide reflection? Doesn't matter. Or if we're going to use the vocabulary from the warm-up, we would say they are commutative. So let's write that. So they are commutative, which means the order doesn't matter. So whichever order you do them in a glide reflection, meaning notice that our translations will not move up or down and then left and right. It will be one or the other. Our reflections are going to be either a vertical reflection or a horizontal reflection. It's not going to be a diagonal reflection. It could be a diagonal reflection, but we won't see that. All right. Any questions here before we look at the next page? So I'm going to go back to a question I asked a little bit earlier today. Is this stuff starting to make a little more sense? Hopefully. Maybe just a little bit, but even a little bit is progress. So let's have ourselves a look at the next question. I know you all came into math today wanting to talk about tires, and so that's why I did this example. I always have people coming to me trying to talk to me about tires and tire tread. So I was like, you know what? I'm just going to put this in an example. It's not real though. Nobody does that. So this is actually an interesting question though, because has anybody ever thought about getting into like law enforcement, like as an investigator, solving crimes and things like that? Yeah. This is what this is about. So right here, it says a digital artist is reproducing a tire tread pattern from a partial tire print at a crime scene by applying a glide reflection. So basically, something that happens in law enforcement is these people who investigate crime scenes, they are called crime scene investigators, kind of like the shows, right? CSI shows. I mean, obviously it's not the same because that's very dramatic, but if somebody was involved in a hit and run and they didn't know, they couldn't find the car that did it, and they were like tire tracks or imprints at the scene, you could actually take an imprint, you can figure out the pattern of the tire, and then digitally reproduce it to figure out who made the tire, how wide the tire is, what kind of cars it fits on. You can narrow down what kind of car it was. And then you could, narrow down your search and figure out who was there at that time, and they would commit that crime and then got away. And so this is basically what we're talking about here. And you can use a glide reflection to basically come up with the tire tread. So it says, she uses the rule of a translation of up 0.1 units. We're not going left or right at all. So it's going up 0.1 units and it's a reflection across the y-axis in order to generate a pattern. Confirm that her rule can be applied to the partial pattern that was taken from the crime scene. So here's the partial pattern here. And so she's applying a reflection across the y-axis. Because remember, when we're talking about composition, we do the second thing first. So the reflection happens first. So reflecting the outline pre-image across the line x equals 0, which is the y-axis. And then apply the second rigid motion, which is a translation of that reflection up 0.1. So taking this and then moving it up 0.1 right here. And it ends up matching exactly the tire tread that was taken from the crime scene. So the rule appears to map the pieces of the partial patterns onto itself. So that would be an actual use of a glide reflection in real life, or a potential use of that. So what we're going to do is we're going to try one by ourselves down here. So what I'd like you to do, and we just talked about this being commutative, so it doesn't actually matter what order you do those two things in. So I want you to graph RSTV, and then I want you to perform both of those rigid motions. And again, it doesn't matter if you reflect or translate first, but go ahead and do both of those. And I don't know, take 3-ish minutes, 3-4 minutes on this. Try to get from RSTV to R prime, S prime, T prime, B prime after both of your rigid motions. And then we'll double check with what I end up having on my paper and we'll see how that goes. Go ahead and finish this one.
Oh, I thought this was, okay.
It is explaining it, but we're going to fill some stuff into it. But yeah, go ahead and do that one too. Yes. All right, so let's take a look. Here's our pre-image, RSTV, putting that in on right here. Now, one of the things about a glide reflection is you could go ahead and draw both of the, next two images that you need to, or you could just go straight to the end. If you want to do the in-between one, you could, but you don't necessarily have to. And so what we're being told to do is to reflect this across the x-axis and then translate it 1 unit to the right. So reflect across the x-axis, translate to the right. And if we want to, we can just do both of those at the same time. So for example, if I start with point R and I reflect R across the x-axis, I'm going to go down 2 to the x-axis and then 2 more. And then if I just move 1 to the right from there, that's going to be R prime. So you don't actually have to do the in-between image if you don't want to. You can go straight from the beginning into the end. If it helps you to put the one in between on there, you're more than welcome to do that. And I'll go ahead and put that here in pencil when we're done with this. For S, we're going to go 5 to the x-axis and then 1, 2, 3, 4, 5 across, and then move 1 to the right. So there's S prime. For T, we're going to go up 4 and then up 4 more, 1, 2, 3, 4, and then 1 to the right. And there's T prime. And then V, up 2 more, 1 to the right, and V prime. So our image should look about like that. Now, if you did the in-between one, let's go ahead and do these ones in pencil here. That would be, and it also depends on which of the two transformations you did first. If you did the translation first, then your in-between one would be the red one moved over 1 and then reflected to be the blue one. Or you could reflect it first, like I did here with the gray one, and then move it over 1 to get to the blue one. So it doesn't really matter the order. It's up to you on that. And it's not asking for us to write down the coordinates of the image, so we don't have to write the coordinates of R prime, S prime, T prime, or V prime. So we can just call it done at that point. Are there any questions about this process? And we've done compositions already, so this isn't really different than what we've been doing. In fact, it's a lot more confined than what we've been doing. Like our options have gotten narrower and narrower. And so in my mind, that makes it almost a little bit simpler because we don't have the potential for like rotations and all the reflections and all that other kind of stuff. It's just reflect it and then move it either left or right and or up and down, but not both. So it's limiting the scope of what we're actually doing. So it's kind of one of those weird units where it starts off like really challenging, and then I feel like it actually gets less challenging as the unit progresses. So I don't know if you feel that way, but that's kind of how I feel. All right. Questions? Anybody need more time on this? Cool. Let's flip it over. We got one more example. So I just want to talk about real quick what a rigid motion is, and then we can go from there. So we all know that a rigid motion is a type of transformation that does not change the original shape or size. And we've actually done every type of rigid motion now. And so any rigid motion is either a translation, a reflection, a rotation, or a glide reflection. Now, glide reflection isn't really one thing, though. It's a composition of a translation and a reflection. So it kind of has to be a rigid motion. So these are all the ways that we have to perform a rigid motion. And so this is our rule here that any rigid motion has to be one of those things. So going from there, we'll take a look at example 4. So this is like the opposite of what we just did. we went from here's points, apply these two things to make the glide reflection. Now it's saying, what are the rules for the glide reflection that's being shown on this paper? So what we need to do first is we need to figure out our translation and then figure out the reflection. And it says you can work backward, but you know, I prefer not to work backward, because if you work backward, then you have to do the opposite of the translation you did, because if you were to move this one left 5, that would be a translation of -5 of the original, or not of the original, but of the new one. But I mean, the original one have to go to the right 5. So I'd rather just start with the original. So the first thing I usually look for is, before I figure out the translation, I try to figure out the reflection, because the reflection is going to be more telling in terms of how it's going to work. And so these two are like upside down versions of each other, right? Like these two lines, this line here needs to be at the top, like this line is up here. So that's going to be a reflection, a vertical reflection, which means that the translation has to be horizontal, because no matter what, whatever type of reflection we have, the opposite movement is true of the translation. So if we reflect vertically, we need to move horizontally. So I would just say, let's figure out how far over we have to move this one to get it to match up with this one over here. So how far to the right does it need to go? So like if K here is going to be above K down there, how far do we have to move it? Let's see, 1, 2, 3, 4, looks like 5. Okay. And then L, if we move L, so it's underneath that L prime right there, it's going to be 1, 2, should be 5, 3, 4, 5. Yeah. So there's L. And then if we move J, it's going to be 5 as well. So there's J. And we don't necessarily need to label these either if we don't want to. We can just go ahead and get them so they're lined up with those 3 points. So then we can figure out what reflection is happening. But we did move our points 5 to the right. So to determine the translation, we're going to write T, parentheses, 5, 0. Because we moved it 5 to the right. And then the reflection here, it's a vertical reflection. So the reflection's happening over a horizontal line. So if we just pick out, I don't know, this value of K and that value of K, figure out how far apart those 2 points are vertically, we're just going to go halfway in between. So how far apart is this point to that point? How far away are those 2 points? 4. So if we go 2 from each one, that'll put us right in between, which will be this line right here. And that is our line of reflection. So what's the equation of that line? Horizontal lines are always defined by y equals, and then just the number where they are on the y-axis. So how far up from the y-axis is that? Just 1, right? There's 2's here, so 1's there, so it's y equals 1. So the reflection, determine the line of reflection, we're going to say it's a reflection across the line y equals 1. And then you can write the complete glide reflection. And because a glide reflection, the composition of a glide reflection is commutative, it doesn't matter what order you put those in your answer. So because we wrote the translation first, I'm just going to go ahead and write that first in the composition. So I'm going to say T, 5, 0, and then open circle, and then R, y equals 1. And that's our answer. Thank you. This is one of those weird units where the math is not the problem. Like we're counting or we're adding or we're subtracting. Like mathematically, the number crunching is not a challenge in any way. It's kind of the visual aspect and like the notation. How do we write this stuff? So that's kind of the thing that becomes the challenge on this type of a unit. Are there any questions on this example here, number 4, before we continue? Okay. I would like you to go ahead and try the 2 at the bottom there. It gives you the pre-image and it gives you the image. It gives the coordinates for each, and it wants you to write the glide reflection as a composition of a translation and a reflection. So try A and try B. By the way, for part B, it's not a full-on shape. It's just a segment from R to S. And by the way, S, that over here, that's a -2. That got cut off a little bit. That's a -2. So I'm gonna say, let's go with 5 minutes. So at 1:26, I'll check back in. We'll see how we do on figuring out the glider reflection rule for A and B down there. Give it a go. I'm gonna work on it as well. I'm gonna show you the first one here. That's what I came up with for the first one. Again, if you went opposite order and you put the x equals -1 first and then the translation second of 0, -3, that's fine, as long as you have both of them. So, if you don't want to draw the in-between one, you don't have to either. So I didn't do that on this one. I just figured, looking at these, by the way, you can figure out the orientation of the two shapes to figure out your reflection. So because the C's were facing towards each other like this, I knew that it had to be a reflection across this way. So that meant it was a horizontal reflection, which meant that the translation needed to be vertical. And so I went ahead and I said, all right, I'm just gonna count from C down to C, that's 1, 2, 3, so there's the -3. And then because C would have ended up in the exact same spot, that meant that this point is on the line of reflection, which is x equals -1, so that's the line of reflection for that. Any questions on A? Anybody have an answer for B that they want to share? What's our translation on B? Is the translation a horizontal or a vertical translation? Are we moving left or right? Or are we moving up and down for the translation? And down? So here's my drawing. And because R to S still goes from left to right, that means we have a vertical reflection. So the shift this time, the translation is going to be horizontal. So what I did first is I counted over to get R above R. 6. So that would be a translation of 6, 0. And then that would put it here and here, which would then reflect across like that. Yeah. 6 here. Yeah, because we're going in a positive direction on the x-axis. Yeah. And then your point R would be here, which is 1, 2, 3, 4 away. And so if you're reflecting it across a horizontal line, reflecting it vertically, that would be across the line y equals 2. So that puts us at right there. 6, 0 for the translation, y equals 2 for the reflection. And if I go ahead and move this one over, so that would be R and then S. So here's R, here's S. So if you translate it, it goes to here. And then it would flip upside down. This one over here would move down 3. So there's, let's see, A would be here, and then B would be here. So A, B, C would move down first. And then it just reflects left to right across that line, x equals -1. Right. Any questions about how to like recognize the different types of reflections and translations that are happening? All right, well, let's see. We've got, what is the advisory? We're out here at 12:42. So we've got actually 13 minutes. That's not bad. So we're going to get started on the assignment.